This lesson covers calculation of tidal heights at standard and secondary ports for RYA Coastal Skipper and Yachtmaster theory students. What's the earliest time I can safely navigate in or out of this harbour, river or estuary, allowing for the draft of my boat, the least depth of water in the approach, and the prevailing conditions? Is there sufficient depth of water for me to safely navigate over this area of shallow water, allowing for the draft of my boat, my confidence in the survey data, ability to continuously confirm my position, and to navigate accordingly in the prevailing conditions? What depth must I anchor in now in order to avoid grounding at low water? If I moor here, will I ground at low water? What's the earliest or latest time I can safely navigate under the bridge, allowing for the air draft of my boat, the clearance height, and the prevailing conditions? Can I safely navigate under the bridge now, allowing for the air draft of my boat, the clearance height, and the prevailing conditions? You should know your vessel's draft and air draft. Charts, almanacs and pilot books will tell you the charted depth and clearance heights under bridges. Tide tables, in conjunction with tidal curves, or perhaps these days a computer or chart plotter, will tell you the height of tide now or at any time you choose. Your echo sounder measures the depth of water below its transducer and can be calibrated to display the depth of water by adding an offset, or the depth under your keel by subtracting an offset. Make sure that you know if and how it's calibrated, and check it regularly with a lead line, which you should carry anyway as a backup. Determining an appropriate safety margin is one of many distinguishing attributes of an experienced seaman. There are many factors to consider. What you're really trying to establish is what the downside is if you do accidentally run aground. For example, running slowly aground on a soft muddy bottom in calm conditions on a rising tide is only a minor inconvenience, whereas running aground at speed on a rocky bottom in rough water, on a lee shore or on a falling tide could mean a serious threat to the lives of all on board and total loss of the yacht. If you run aground on a falling tide, unless you get off very quickly, you're going to be there until the tide falls to low water and rises again above the height it was when you ran aground. If you ran aground just after high water, it might be nearly 12 hours. You really do not want to run aground at high water springs, because it might be weeks before you can get off without suffering significant damage. This is called being neaped, and it has been known for vessels to be neaped for months if they ran aground at the top of an especially big spring tide. Those who are used to sailing in the muddy rivers and creeks of the Solent or East Coast need to recalibrate their thinking when sailing in rocky areas like the Channel Islands. Obviously, if the charted depth were 2 meters and the height of tide was predicted as another 2 meters, then in calm conditions, give or take, you might expect a depth of 4 meters. However, even 1 meter waves will erode this by 50 centimeters, and, as every surfer knows, if the average wave height is 1 meter, every so often 1 or 3 meters will come along, and the last thing you need is to punch your keel up through the bottom of your boat as you fall off a wave. Remember, a lee shore is one you're being blown onto, and lee shores were greatly feared by sailors before auxiliary engines gave some hope of clawing the vessel off. As you learned in the lesson about charts, some areas close inshore have not been surveyed for donkey's years, and it's very dangerous to assume that your GPS or chart plotter will keep you safe. Sandbars can move, and frequently do after storms. If the shallow channel you intend navigating is indistinct or poorly marked, you need a well-prepared pilotage plan which you can execute accurately. Allow an extra margin at night in poor visibility and strong winds. Extreme weather conditions, such as unusually low or high barometric pressure, or gale-force winds blowing continuously from one direction, can result in tides substantially above or below predicted levels. And what about your type of keel? Fin-keeled yachts can sometimes be heeled over using their sails, or even crew weight, in order to reduce their draft to help escape a grounding. But this will not work for bilge and wing-keeled yachts. On the flip side, bilge-keeled yachts can sometimes safely dry out on a firm, relatively level bottom to wait for the next tide. And skippers of yachts with lifting keels have a get-out-of-jail-free card. So it's up to you. On a rising tide, in calm conditions and a soft muddy bottom, you can feel your way in or out of a creek at very low risk. However, sailing over rocks, on a lee shore, on a falling tide, in big waves, is an entirely different matter. We can find the time and height of high water and low water from tide tables. Almanacs only publish the times and heights at standard ports, which are major ports. Other harbours, estuaries and rivers are secondary ports, and if you need to establish times and heights at secondary ports, you need either a full set of Admiralty tide tables, or a local set of tide tables, or to apply corrections to the times and heights for the associated standard port, or to use a computer. Admiralty tide tables detail the times and heights of high and low water for over 230 standard and 6,000 secondary ports in the UK and Ireland, Europe, the Indian Ocean, South China Sea, and Pacific Ocean for each day of the year. The tables outline methods of prediction, the effect of meteorological conditions on tides, and provide additional information on exceptional tidal factors in each area. The tables are available from Admiralty distributors worldwide in 4 volumes and cost £30 per volume. Local tide tables are available from a number of sources, and if your home port is a secondary port, it's useful to obtain a set, perhaps from the local harbour master or chandlery. Alternatively, www.tidetimes.org.uk publishes tables for over 698 UK locations, and you can buy them individually online for just £1.49 each, plus postage and packing. See the Resources tab. Many chart plotters and computer programs, including apps for mobile devices, can deliver not only times and heights for high and low water, but also the height of tide at any time between high and low water. UKHO offer EasyTide, www.ukho.gov.uk, which delivers free predictions for up to 7 days ahead. See the Resources tab for a link. Hopefully, you're already able to confidently employ tide tables from an almanac, together with their associated tidal curves, to predict the height of tide for any standard port at any time. But, just to make sure, let's run through it quickly. Imagine we need to establish the height of tide at Port Fraser at 0900 on Friday the 8th of March. If you go to page 48 in your RYA almanac, you can see that there is a high water of 3.4 metres at 0654 and a low water of 1.2 metres at 1311. So, we're on a falling tide, and at 0900 the height will be something less than 3.4 metres, but more than 1.2 metres. Now you need the associated tidal curve. It's on page 51 of your training almanac, but if you wish, you can print a copy from the Resources tab, so that you can keep it with your notes. When you've got it in front of you, mark the time of high water into the box at the bottom in the centre of the curve. And then work forward to the time we're interested in, which is approximately 2 hours after high water. Now mark the height of high water on the scale at the top of the graph. and the height of low water on the scale at the bottom of the graph. Join the two with a straight line. The line is known as today's curve. Note that there are two curves, one in red for the pattern of the rising and falling tide on springs, another in blue for neaps. Sometimes the curves are coincident, at others they diverge. The best way to determine which curve to use is to calculate the range of this tide, which is the difference between the heights of high and low water. So 3.4 minus 1.2 equals 2.2 meters. If we then look at the mean spring and neap ranges in the box in the top right-hand corner of the graph, we can see that a range of 2.2 meters is very close to the mean neap range. So we will use the blue neap curve. If the range of this tide comes out somewhere between the mean spring and neaps, we can interpolate by eye between the two curves. However, we must never extrapolate outside the curves, meaning that if, for example, this were an exceptionally big spring tide with a range of, say, 4.5 meters, we would simply use the red spring curve. Now draw a line vertically up from the time we are interested in, which is just after 2 hours after high water, until it meets the neap curve. And from the point of intersection, horizontally across, until we meet today's curve. And then up or down, doesn't matter which, to the scale on the top or bottom of the graph. And read off the predicted height of tide, which is 2.8 meters in this example. Now answer this question. You should get an answer of around 22:15. If we examine a large-scale chart of the entrance to Port Fraser, or better still, consult the pilotage notes in the almanac on page 46, we can see that the least depth in the inner swashway is 0.7 meters. So, as you learned in the tidal theory lesson, the minimum height of tide necessary is your draft, in this case 2 meters, plus the safety margin, 0.5 meters, less the charted depth, 0.7 meters, equals 1.8 meters. From the tide tables for Port Fraser, you will discover that there is a low water at 19:38 and a high water at 01:58 early the following morning. And since the question asks what is the earliest time on the evening of the 2nd of January, you can infer that you are being asked to find the earliest time after 1938 you can enter. So 01:58, or let's call it 0200, is entered into the graph as a time of high water. The height at 01:58 is 4 meters, and it's 0.8 meters at the preceding low water. We need 1.8, so we can drop a line down from there to today's curve, and then horizontally across to the tidal curve, which in this case is the same for springs and neaps, and then down to a timeline to find that the earliest we can safely enter is around 22:15. Note incidentally that each hour on the timeline is divided into 2 periods of 30 minutes and 6 periods of 10 minutes. As you learned earlier, unless you're equipped with a full set of Admiralty tide tables, or local tide tables, or a chart plotter, or computer, or mobile phone tidal prediction application, you need to know how to calculate times and heights of tides at secondary ports. You accomplish this by applying corrections to the times and heights for the associated standard port. Take a look at page 65 in your almanac. Look backwards and forwards a page or two. You won't find any tide tables for Rozelle Cove, because it's a secondary port. The table at the top of the page tells us that its standard port is Port Fraser. Notice the little arrow next to Port Fraser. This tells us that the tide tables for Port Fraser appear earlier in the almanac. The table has 8 columns. The first column tells us that if high water Port Fraser is exactly 0000 hours, or 1200 UT, then high water Rozelle Cove will be 38 minutes earlier. So, for example, if high water Port Fraser were at 1200, high water Rozelle Cove would be at 11:22. Whereas the second column tells us that if high water Port Fraser is at 0600 or 1800 UT, then high water Rozelle Cove will be 18 minutes earlier. And if high water Port Fraser were at 1800, then it would be 1742 in Rozelle Cove. Which is all well and good, but what if the time of high water was some intermediate time? Imagine high water Port Fraser were at 0900. 0900 is exactly halfway between 0600 and 1200. So high water Rozelle Cove would be exactly halfway between minus 18 minutes and minus 38 minutes, which is minus 28 minutes. So at 0832. It gets substantially trickier if the time of high water at the standard port is at some random point between those given in the column headings. For example, at 0745 in Port Fraser. Those who are good at arithmetic might get to an answer like this. But if you're like your instructor and the other 99.9% of the population, you've just suffered apoplexy and you might want to consider using a simpler method. You need a set of crocodile teeth. Start by drawing a horizontal line to represent the difference, which ranges from minus 18 minutes at a high water time of 0600 to minus 38 minutes at a high water time of 1200. Divide it into 20 1-minute intervals. Then draw a line at an angle to represent the interval, which ranges high water at 0600 to high water 1200, and divide it into 6 hourly intervals. Notice that the lines intersect at 0600, minus 18 minutes. Now draw a line from 1200 to minus 38 minutes. You can then find the difference at any time by drawing a line parallel to this line, in red. If we position one with its upper end at approximately 0745, we can see that its lower end is approximately minus 24 minutes. Therefore, high water Roselle Cove will be at 0721. The interval is normally, but not always, 6 hours, as these different tables illustrate, and the difference might range from later to earlier, or vice versa. So creating the crocodile teeth takes some careful thought. Also, be aware that when you read a difference of, for example, minus 0110, this does not mean minus 110 minutes, but 1 hour and 10 minutes. If you regularly sail in and out of a secondary port, you can create a set of crocodile teeth, laminate them, and keep them to hand, writing on them with a wax pencil. You also need to know that the times for high water at the standard port are given in the standard time zone for the port, for example, UT in the British Isles. This means that in daylight saving time, you must calculate the times of high water and low water at the secondary port based on the times given in the almanac, and then convert them to daylight saving time. Most of the time, we're not concerned with the exact time of low water in a secondary port, because tidal curves are centered on high water. But if you do need to find low water, it's exactly the same process. For example, if low water Port Fraser is at exactly 1100 or 2300, then low water Roselle Cove will be 14 minutes earlier. The exception is in the rare circumstances when either the standard port's tidal curve is centered on low water, or exceptionally in the Solent, where, because of complex mixed tides with double high waters, you have to use curves specific to groups of secondary ports, also centered on the time of low water. In the RYA world, Dunbarton, whose curve you'll find on page 43 of your training almanac, is centered on low water. The heights of high water and low water can also be found by interpolation or crocodile teeth. If the height of tide at high water in Port Fraser is 4.2 meters, then it will be 0.2 meters more in Roselle Cove. In other words, 4.4 meters. Whereas, if it's only 3.4 in Port Fraser, it'll be 0.2 less in Roselle Cove, so 3.2 meters. A variation on crocodile teeth is needed because the actual height of high tide on the day in question might be higher than mean high water springs or lower than mean low water springs, which means you will need to extrapolate the difference. Notice how the difference and height lines cross at minus 0.2 and 3.4. Interpolating between a high water height of 3.4 and 4.2 could, for example, tell us that if high water Port Fraser were 4, then it would be 0.1 more in Roselle Cove, so 4.1 meters. However, if the height of tide in Port Fraser were 4.3, then it would be about 0.25 meters more in Rozelle Cove, so 4.55 meters. At the other end of the scale, if high water Port Fraser were 3.1 meters, the difference at Rozelle Cove would be 0.35, which will round up to minus 0.4, so 2.7 meters. Obviously, the same process can be applied to finding the height of tide at low water. So let's put it all together. I strongly recommend that you work through this with me. You can print a copy of the Port Fraser tidal curve from the Resources tab. What is the time and the height of high water and the height of low water at Rozelle Cove during the day on the 25th of April? High water Port Fraser is at 10:16 UT. Using Mr. Crocodile, we can see that it will be 32 minutes earlier in Rozelle Cove. So 10:16 minus 32 is 09:44 UT, which is 10:44 daylight saving time. The height of high water in Port Fraser is 4.1 meters, which gives a correction of about plus 0.15 at Rozelle Cove, so 4.25 meters. The height of low water in Port Fraser is 0.7 meters, which gives a correction of somewhere between plus 0.3 and plus 0.35. We don't need to be that precise, so if we err on the cautious side, we can use plus 0.3, giving 1 meter. Then, if we need to find out, for example, when the height of tide in Rozelle Cove will fall below 3 meters during the afternoon of the 25th of April, we simply plug the time of high water and the heights of high water and low water into the relevant standard port curve, Port Fraser in this case. The range of this tide at Port Fraser is 3.4 meters, which is pretty much smack in between Springs and Neeps. So we interpolate between the curves, arriving at an answer of 1300. Now it's over to you. What is the height of tide in Edenfield in the Southern Peninsula at 0900 local time on the 19th of September? You will need a Hamilton tidal curve, which you can print from the Resources tab. If you came close to 3 meters, give yourself a big pat on the back. Here's how we get there. The standard port for Edenfield is Hamilton, and you can see that if high water Hamilton is at 0800, then Edenfield will be 12 minutes earlier. And if high water Hamilton is at 1400, Edenfield will be 18 minutes earlier. You could argue that the difference between 18 and 12 is so small it's not worth interpolating accurately between the two, and in real life you'd probably just eyeball it and plump for 15 minutes earlier, banging between the two. But you need to know that you can do it properly. So I would expect you to have drawn and used a crocodile diagram, like this one, and come up with somewhere between 15 and 16 minutes. If we take 15, because we're on a rising tide, that gives high water Edenfield at 11:59, according to the town hall clock. "5.3 meters height of tide at high water in Hamilton gives a difference of roughly minus 0.3 in Edenfield, so 5 meters. "1.3 meters height of tide at low water in Hamilton gives a difference of roughly minus 0.3 in Edenfield. If we are on the safe side, so 1 meter. Now we simply plug these numbers into the Hamilton graph, and bingo! 3 meters. In areas where the tidal curve is approximately sinusoidal, you can make a good approximation of the height of tide using the rule of twelfths. The idea is that in the first hour of the tide's rise or fall, it rises or falls 1/12 of the range, and in the second hour 2/12, 3 in the third, 3 in the fourth, 2 in the fifth, and 1 in the sixth. This means that the cumulative rise or fall is 1/12 after the first hour, 3/12 after the second hour, 6/12 after the third hour, 9/12 after the fourth hour, 11/12 after the fifth hour, and 12/12 after the sixth hour, which is high water or low water, depending on whether it's a rising or falling tide. If you're good at mental arithmetic, and with a bit of practice, you can then work out a good approximation of the height of tide. For example, if high water was 5.3 meters at 1300, and the next low water is 1.7 meters, then the range of the tide is 3.6 meters. And if you wanted to calculate the height of tide at 1700, 4 hours after high water, when the tide will have fallen 9/12 of its fall, you would multiply 3.6 by 9/12, getting a fall at 1700 of 2.7, and resulting in a height of tide at 1700 of 2.6 meters. Now it's your turn. High water will be 7.8 meters at 1800. The previous low water is 0.6 meters. What will the height of tide be at 1700? The answer is 7. Here's how to get there. Okay, that's the lesson over. Now go on to exercise C. Brace yourself, it's a big 'un.